All right, let's talk about geometric series. The sum of the terms of an infinite geometric sequence is called an infinite geometric series, or just geometric series for short. Now, the thing is we've got to remember, if I take a number that is greater than 1, like something like 3/2, and I start multiplying it by itself, I get 9/4, which is greater than 3/2. And if I multiply 9/4 by another 3/2, I get 27/8, which is greater than the term before it. So by multiplying by a number greater than 1, as we do this infinitely many times, our terms are going to get infinitely large. Therefore, there will not be a sum. On the other hand, if I take a number that's smaller than 1, like 2/3, and I multiply it by 2/3, I get 4/9, which is smaller than 2/3. And if I multiply 4/9 by 2/3, I get 8/27, which is even smaller than 4/9. And if we continue this process forever, this gets smaller and smaller and smaller, and it tends toward or approaches 0. So we have this idea that if you take the formula for the sum of a finite geometric sequence and allow n to get arbitrarily large, that is to say, n goes to infinity, then for specific values of r, that formula can be extended. So again, if I take that formula that s is a1 times 1 minus r to the n over 1 minus r, if as n goes to infinity, as n gets large, r to the n would go to 0, and my formula simplifies to a1 times 1 over 1 minus r, or a1 over 1 minus r. Right? And again, we've got a couple different forms here. It's better always to start with trying to get the index to be 1 in that case. So example 7, find the sixth partial sum. So again, I want that S6, and then find the sum of the series. So to do that, I need my first term, I need my r, I need my n, which would be 6. R is that base of the exponential, 0.6. And a1 is going to be what I get when I plug in 1. So 1 minus 1 is 0. 0.6 to the 0 is 1, times 4 is 4. So S6 is going to be a1 times 1 minus 0.6 to the 6th over 1 minus 0.6. And if we multiply all of that out, I get 9.53344. The sum of the series, first of all, 0.6 is less than 1, so we do have a sum. So it's just going to be that a1 over 1 minus r. 1 minus 0.6 is 0.4. 4 divided by 0.4 is 10. And the last one. And this one here is one of those problems where you could probably figure this out just by looking at it and saying, hey, if I add 3 plus 0.3, I get 3.3. And if I add a 0.03 onto that, then that's going to put a 3 here. And if I add a 0.003 onto that, it's going to put a 3 here. And you could probably see where this is going. But again, let's take a look at it analytically. Our first term here is 3. From one term to the next term, we multiply by 1/10. Or if you put 0.3 over 3, you'll get 1/10. So that's our r. Again, r is less than 1, so we do have a sum. And this is an infinite sum. So s is going to be a1 over 1 minus r. 1 minus 9/10, 1 minus 1/10 gives me 9/10. Take the top, multiply it by the reciprocal of the bottom, simplify, and we get 10/3, which is that 3.3 repeating that we see up here. And there it is. That takes care of everything with geometric series.